All right, so this is lesson 12.8 for Honors Algebra 2. We're going to be talking about translations of trigonometric graphs using our 6 parent functions that we saw from our last lesson. We also learned what happens when we multiply numbers inside and outside the trig function. Today we're going to focus on what happens when we add and subtract numbers inside and outside the trig functions. All right, so then what happens actually is horizontal translations and vertical translations. And just so you know, a horizontal translation is also known as a phase shift. So that means we're shifting the graph either left or right. And a vertical translation is when we shift the graph up and down. All right, so I like this summary right here of all the things that you can do to a trig function. Okay, so from the previous lesson, if we multiply outside the function, this affects the amplitude of the graph. And if we multiply inside the function, that affects the period of the graph. All right, now what's new is what happens when we add or subtract something inside the function. That would create a phase shift. So it's going to shift the graph either left or right. If h is positive in this case, then it will shift to the right. If h is negative, it would shift to the left. And then lastly, if we add or subtract outside the function, that creates a vertical shift. All right, so that's gonna, if k is positive, it'll shift the graph up. If k is negative, it'll shift the graph down. All right, now easy ways to help you remember these things. Just remember if what's happening to your equation, either multiplying or adding or subtracting, is outside of the function. All right, so this is the function right here. Okay. So what's happening outside the function is going to affect the graph vertically. Okay, so it's going to stretch vertically if it's being multiplied. It's going to shift vertically if it's being added or subtracted. These guys inside the function, right? So the b and the h, this is inside the function. So if it's inside the function, it's going to affect the graph horizontally. So for example, b affects the period, so it can stretch or compress the graph horizontally, and the phase shift is also horizontal. And this is something you can use even outside of trig functions. This applies to any sort of function when you're graphing. If something's happening inside the function, it affects it horizontally. If it's happening outside the function, it affects it vertically. All right, so let's go ahead and jump into some examples. Okay, so for number 1, it says, state the amplitude, period, phase shift, and vertical shift for each function, then graph the function. All right, so let's go ahead and find all 4 of these things, starting with the amplitude. All right, so the amplitude is affected by what's being multiplied outside the function. So in this case, we have 1/2. The period, I can see that we're in degrees right here, but the period is going to be affected by what's being multiplied inside the function, the cosine function. So if you remember, it's the original period of 360 divided by what's being multiplied inside the function, which is that 3, giving me 120 degrees for my period. All right, phase shift, and I'm going to just abbreviate that PS, is what's being added or subtracted inside the function. So we see that 90 degrees. Now notice in the kind of general formula here, it's a minus sign inside. So here, h is actually positive 90, which means that we have a phase shift 90 to the right. Okay, all right, make sure you specify the direction. And vertical shift, I'm going to label that VS. Nothing is being added or subtracted outside the function here, so there is no vertical shift, so I'm just going to write none. All right, so that answers the first part of the question, and now I need to graph. Okay. Now there's different strategies on how to do this. I'm going to show you one strategy that I like to use, which is to focus on what's called the key points of the graph. And those are kind of like the 5 key points of the graph where it hits its max, the middle, and the minimum. Okay. You can also just do this visually if you're very good at being able to apply all these different transformations visually. You are definitely welcome to do that. But this method, focusing on the key points, just kind of keeps it organized. So if you like this method, feel free to use it. If you can use a different method, feel free to use whatever method works for you. All right, so let's start with the key points here, and I'll go ahead and do it down here while I have a little more space. Okay, so what I'm going to do is I'm going to write down the key points just for the original parent graph of cosine. All right, so I'm talking about y is equal to cosine of theta. All right, so if we're just looking at cosine without any transformations, it starts off at 0, 1. All right, and we're in degrees, so at 90 degrees, it goes to that middle point of 0. Then at 180, it goes down to -1. 270, it goes back to that middle point of 0. And at 360, it goes back up to 1. All right, so that is cosine, just the original parent graph. Okay, next I'm going to go ahead and I am going to incorporate the amplitude and the period. All right, so talking about that 1/2 in the front being multiplied and that 3 being multiplied inside. All right, so to do that, to incorporate the amplitude, remember it's outside the function, so it's going to affect my graph vertically. Amplitude and period. And then the 3 inside the function is going to affect the graph horizontally. All right, so let's go and start with the period actually. So the period I know I calculated was 120 degrees. So I know that if I start at 0 degrees, I'm going to end up at 120 degrees at the very end to complete one period. All right, and the rest is just evenly divided. So halfway would be 60, halfway between 0 and 60 is 30, and then 3/4 away would be the 30 plus the 60, giving me 90. All right, so that takes care of the period. Now the amplitude, I'm going to multiply all my y coordinates here with that 1/2. All right, so 1 times 1/2 gets me 1/2. 0 times 1/2 is still 0. -1 times 1/2 is -1/2, 0, and 1/2. All right. So for the amplitude, all you do is multiply the y coordinates of the original by that 1/2. All right, that we see in that equation being multiplied right there. Okay. If it was -1/2, I would multiply -1/2. But it's not. Okay. Next one, I'm going to go ahead and now incorporate the phase shift and the vertical shift. All right, so phase shift and vertical shift will give me my final set of points. So the phase shift, I'm literally just going to add that 90 degrees to all my x coordinates. So I get 90, 120, 150, 180, and 210. All right, so I'm adding to my x coordinates for that phase shift. And then for the vertical shift, I would add to the y coordinates, but because my vertical shift is none, I just maintain the same y coordinates that I have from before. All right, so here are my final key points of my graph. So now I just need to graph it. All right, so here I notice I'm going from 90 to 210, and you just gotta make sure you have even intervals. So I notice I'm jumping 30 each time. So I'm gonna go ahead and make my marks worth 30. So 30, 60, 90. This is 120, 150, 180, and this is 210. All right, and now I just need to plot my points. 1/2, I'll go ahead and mark here as 1/2. Down here at -1/2. And I start just plotting those points right here. Okay, so at 90 I'm at 1/2. At 120 I'm at 0. 150 I'm at -1/2. 180 I'm back at 0. And at 210 I am at 1/2. All right, and now make that wave, connect those dots. All right, and that is one period of your cosine function. It looks kind of funny like that, so I'm going to go ahead and show that it does continue. I'm just going to follow that pattern. At 60 it would be at 0. At 0 it would be at -1/2. And it just keeps on going. All right, and that is my final answer for the graph. Okay, let me show you another example, number 2. Okay, this time we have tangent. All right, so with tangent, let's start by identifying the amplitude. In this case, the amplitude would be none since it's tangent. And the period, notice I have nothing being multiplied inside the function. So the period will stay the same. Looks like I'm in radians with that pi/4. All right, so then my period will stay the same as the parent function at just pi, because we're in tangent. Okay. And then our phase shift, I have this plus pi/4. So this is going to be pi/4 to the left. And vertical shift, nothing is being added or subtracted out here. So vertical shift will be none as well. Okay. All right, so let's go ahead and let me show you how I use my key points for this one. All right, so key points, I'm going to start with the parent function, just y is equal to tangent with no transformations. All right, so tangent starts at 0, 0. And then at pi/4, it goes up to 1. At pi/2, it's undefined. There's an asymptote, so I'll mark that as undefined. At 3 pi/4, it's at -1. And lastly, at pi, it goes back to 0. All right. So our next step is to incorporate the amplitude and the period. Now, in this case, there's nothing being multiplied outside or inside besides 1. Okay. So because of that, the amplitude will stay the same and the period will stay the same. So I'm not going to rewrite these all again. I'm just going to write same. Okay, so the only thing that's really happening here is this plus pi/4 on the inside. So we have a phase shift no vertical shift, but if I had one, I would, you know, use that here or make the changes I need to the key points here. But I have pi over 4 to the left. So I'm going to subtract pi over 4 to all my x coordinates. Okay, so subtract pi over 4 to all your x coordinates. All right, and because there's no vertical shift, that means all your y coordinates get to stay the same. All right, so these are the key points of your final answer. So notice each jump is pi over 4, so I'm going to go ahead and make each tick mark on my graph equivalent to pi over 4, starting at negative pi over 4 right here. Okay, that's 0, pi over 4, yeah, pi over 2, and then 3 pi over 4. Okay, and so just kind of follow that same flow or same picture as the parent graph, starting at 0, and then 0, 1, I'll mark that as 1, goes up here, mark that as negative 1. Pi over 4, I have an asymptote, so dash vertical line right there. At pi over 2, I'm at negative 1, and at 3 pi over 4, I'm at 0. Alright, so we get that nice tangent graph approaching the asymptotes from positive and negative infinity. And I'll continue those arrows just to show that it keeps on going. All right. So go ahead and flip to the next page, and let me do one more for you that has everything in it, and the rest I'll have you practice. All right, so a lot of good practice here. Let me see. Let me do number 5. All right, so number 5 looks like it has pretty much every possible transformation you can have. So let's see how that looks like with our sine function. Okay, so let's start with identifying, again, the amplitude, the period, the phase shift, and the vertical shift. All right, amplitude we have is 3. Period, I'm in radians here, so it's going to be 2 pi for sine divided by that 2/3 that's being multiplied out here, and I get 3 pi for that period. Phase shift is going to be pi to the right, and vertical shift will be 4 up. All right, so we got a little bit of everything in this problem. Okay, so let me go ahead and start with my key points. Okay, giving myself a little more space. All right, and so for sine, the parent graph, my original key points, starts at 0, 0. That pi over 2, it goes up to 1. Pi goes to 0. 3 pi over 2 goes to negative 1. And at 2 pi, it's at 0. And I find it easiest to remember those just by visualizing the graphs. I see that kind of wave formation. So I go middle, up, middle, down, middle. All right, my next step, I'm going to go ahead and incorporate my amplitude and period. All right, so my period, I'll start by changing my x coordinates to going from 0 to the 3 pi I found before, and then dividing that in half, giving me 3 pi over 2, right in the middle. And dividing that distance in half gets me 3 pi over 4. And then adding these two together would get me 9 pi over 4 for that last x-coordinate. Okay, so my amplitude here is 3, so I'm going to multiply all my y-coordinates by 3. Quick note here, for the amplitude, if that 3 was negative, here for amplitude I would still write positive 3 because amplitude is a measure of distance. All right. However, when I get to this step with the key points, when I multiply, I would multiply all the y-coordinates by -3. And that kind of allows you to see that reflection across the x-axis. All right, so just remember this amplitude right here is always positive, but when you multiply the y-coordinates for your key points, multiply it with the negative if the negative is there. All right, let's go ahead and go on to, excuse me, the phase shift and vertical shift. All right, so my phase shift, I have pi to the right. Vertical shift, I have 4 up. All right, so phase shift, I'm going to go ahead and add pi to all my x-coordinates. All right, so 0 plus pi gets me pi. 3/4 of pi plus 1 more pi gets me 7 pi over 4. And then 5 pi over 2. And then 13 pi over 4. And then 4 pi. All right, in the vertical shift, I have 4 up, so I'm going to add 4 to all my y coordinates. All right, and these are the key points to your final graph. Okay, so let's go ahead and see what to do here for my final graph. Excuse me. I do notice I am jumping 3 pi over 4, okay, for each of these jumps. So I'm going to go ahead and I'm just going to make each tick mark worth 1 pi over 4. And I think that's the cleanest way to do that one. All right, so I got 1 pi over 4 here, 2, 3 pi, okay, then 1, 2, 3, 4 gets me 2 pi, and then 1, 2, 3, 4 gets me 3 pi, 1, 2, 3, 4 gets me to that 4 pi. Okay. All right, just kind of creating those even intervals. And then I notice that I am going from a lowest point of 1 in my y-coordinate here, and the highest is 7. So 1, 2, 3, 4, 5, 6, 7. Okay. All right, and now I just need to plot those points. So the first point is pi over 4, so that gets me right here. And then remember, each jump is worth 3 pi over 4, so I'm going to jump over 1, 2, 3, and that should be 7 pi over 4 right at y-coordinate of 7. And if you want to write down 7 pi over 4 there, you're more than welcome to. Jump another 3 steps. 1, 2, 3 gets me 5 pi over 2. Write 4. Another 3 steps. 1, 2, 3 gets me, this is 13 pi over 4, down to 1. Then 1, 2, 3, last stop at 4 pi, giving me a y-coordinate of 4. All right, so I have a nice sine graph that looks like that. And again, if you want to continue that, to show that arrow, that it keeps on going. On the left-hand side, we can even go backwards. We can go 1, 2, 3, and we know that that would be down here at 1. So we want to kind of continue that graph to show it keeps on going. Okay. So why don't you guys go ahead and practice what you need to. You got plenty of practice problems here. So pause the video, and once you're done, I'll go and show you all the answers to the rest of these problems. All right, so here are some answers. Number 3, I'll go ahead and just pause on that, let you guys look through the amplitude, period, phase shift, and vertical shift, and look at those 5 key points I got at the end, and then my graph. All right, number 4, I got amplitude of 1, period of 180 degrees, phase shift is 60 degrees to the right, and vertical shift is none. Here are my key points, and those are my graphs. All right, and number 6, for amplitude, I got 4, period of pi, phase shift pi over 2 to the right, and vertical shift 1 up. Here are those key points, and there's my graph. And I darkened the part that represents the key points. All right, and number 7, amplitude would be none, since it's cosecant, period of 120 degrees, phase shift 45 degrees to the right, and 1 up for vertical shift. All right, and those are my key points and my graph. Okay, and the last one, number 8, amplitude also none, period of 720 degrees, phase shift of 90 degrees to the right, and vertical shift was 1 down. All right, and then those are my key points and my graph. Okay. So just a couple of notes in terms of the key points and work and things like that. Again, like I said at the beginning, this stuff right here is optional work. I know some people, they're able just to kind of visualize it and be able to make their shifts and stretches, compressions, just visually on the graph. So if you want to jump straight to the graph, that is totally fine. So this stuff is optional. But what I do want to see are actually those 5 key points plotted very clearly. Okay, so you don't have to show it here in the coordinates, but you do have to show it visibly on the graph, and that's what I'll be looking for on these trig graphs. All right, and that is it for lesson 8.